Hey there, scientists! Caroline here. In our last lesson, we looked at the evidence for climate change. We saw that Earth's average temperature has risen by about 1.7 degrees Celsius or 3 degrees Fahrenheit in the past 200 years. But it's only a few degrees, so what's the big deal? In today's lesson, we're going to be investigating what a few degrees means for us now and how it can impact us in the future. Ready, scientists? Let's get started. Earth is a system, which means its different parts, the atmosphere, hydrosphere, geosphere, and biosphere, are all connected. Think back to what we've learned about how temperature impacts the hydrosphere. If the average temperature of the air increases, how might this impact the water cycle? Pause and record your thoughts in your guided notes. You might have said that rising temperatures increase the speed of the water cycle, and you'd be right. When sunlight heats Earth's surface, water evaporates, changing from a liquid to a gas. That water vapor then carries heat energy into the atmosphere, where it fuels weather systems. A difference of 1 to 2 degrees might not seem like much, but remember, it only takes a fraction of a degree to make a single water molecule evaporate from a liquid to a gas. Even a small temperature rise globally means a lot more water evaporating and entering the atmosphere. More water vapor in the atmosphere means more energy moving through weather systems. And more energy moving through weather systems means more extreme and unpredictable weather events overall. Weather systems are complex, so these effects can play out in a variety of ways. Some regions might see record rainfall one month, while others face longer droughts. One region might experience historic heat waves one week, while another deals with unusually cold temperatures. And storms, like hurricanes along the coast, can increase in frequency and intensity. In this way, 1 to 2 degrees creates big changes with far-reaching consequences. So, what do these changes mean for us? Throughout this course, we've been exploring environmental science through 3 lenses: economic, social, and environmental. Let's apply that same approach to understanding climate change. When we view the problem from all 3 angles, we're better equipped to consider meaningful solutions. Let's start with the economic lens. We know that climate change is leading to more extreme weather events. Scientists, how do you think more extreme weather impacts the economy? Pause and record your thoughts in your guided notes. You might have said that stronger storms cause more damage to cities, leading to costly repairs. For example, in 2012, Hurricane Sandy caused massive flooding along the U.S. northeast coast, far more than the region was prepared to handle. The price tag for repair costs? Over $70 billion. It was a wake-up call. Climate change is making the aftermath of extreme weather more expensive. But storms aren't the only concern. Droughts, heat waves, and cold fronts are also becoming more intense in a warming world, and they carry serious economic consequences. In California, for instance, longer drought seasons are fueling wildfires and increasing the costs of fighting them, requiring more personnel, equipment, and emergency response. Droughts can also lead to higher grocery prices, as reduced rainfall creates challenges for farmers and ranchers. And extreme temperatures, whether hot or cold, can also overload power grids, driving up electricity bills and increasing the risk of blackouts. In all of these ways, climate change is raising the cost of living, not just for individuals, but for entire communities and national economies. But not all the costs of climate change can be measured in dollars. Some of the most devastating impacts are social, when people lose their homes, their security, and even their ways of life. A powerful example is Lohachara Island, once located in the Sundarbans Delta near India and Bangladesh. Rising seas and erosion have displaced thousands of people who lived there for generations. This isn't an isolated case. Coastal communities around the world face similar risks as sea levels rise. Climate change also threatens access to food, especially in rural farming regions. Shifting rainfall patterns and increasing heat can lower crop yields, creating food shortages and insecurity. When we look closely at these examples, a pattern emerges. Smaller rural communities, which often contribute the least to global greenhouse gas emissions, are often hit the hardest by the impacts of climate change. And it's not just people feeling the pressure. Ecosystems are struggling to adapt to new climate conditions as well. In the Great Barrier Reef, warmer waters are leading to coral bleaching, causing a decline in species that depend on coral. In the Mississippi River Delta, stronger storms have pushed saltwater into freshwater wetlands, destroying habitats for fish, birds, and amphibians. And in the North Pole, melting sea ice is making it harder for animals like polar bears to survive. These are just a few examples that indicate a larger trend. Climate change is causing a loss of biodiversity over time. Fewer species, weakened ecosystems, and a planet that's harder for all of us to live on. Even though a global temperature rise of just 1 to 2 degrees might not sound like much, the impact on people, wildlife, and the environment can be far-reaching. Understanding these economic, social, and environmental impacts helps us recognize the changes already happening and prepares us to adapt more effectively. For example, Australia is now offering a special pathway to citizenship for people from Tuvalu, an island nation threatened by rising sea levels. This kind of response shows how understanding today's risks can help us make more informed choices and start building safer, more climate-ready communities. But this also raises another important question. What does climate change look like in the future? As the planet warms, the effects of climate change don't just continue, they can actually speed up. This is called climate change acceleration, and one key part of it starts at the poles. Think about it this way. When you're out in the sun, do you feel warmer wearing a white shirt or a black shirt? A black shirt feels warmer than wearing a white one, right? That's because dark colors absorb more heat from the sun, while light colors reflect it. Now imagine that same idea on a global scale. This is what ice and ocean water look like from space. How do you think melting ice might influence Earth's temperature over time? Pause and record your thoughts in your notes. When white ice, which reflects sunlight, melts and is replaced by dark ocean water, more heat is absorbed instead of reflected. That extra heat then causes more ice to melt. This is called the albedo effect. It's a feedback loop, a continuous cycle of more warming, more melting, more heat absorption, and even faster warming. Now you might be thinking, Caroline, that sounds like pretty bad news. Isn't there any good news? And yes, there is. The good news is that once we understand these processes, we can work to slow them down, stopping feedback loops and climate acceleration in their tracks. The choices we make today as individuals, communities, and countries can help reduce greenhouse gas emissions, protect ecosystems, and support people most at risk. Climate change isn't just a science issue. It's a challenge that connects to everything: food, money, health, and ecosystems. Learning about climate change is the first step toward creating solutions. And with that, we've wrapped up our lesson on the impacts of climate change. We've learned that as average global temperatures rise, the water cycle speeds up, leading to more intense natural disasters like storms, droughts, and heat waves. These changes come with serious economic, social, and environmental costs, affecting both people and wildlife around the world. But here's the good news. Climate change isn't unstoppable. The more we understand how these systems work, the better prepared we are to adapt, protect ecosystems, and reduce the risks ahead. In our next lesson, we'll explore global solutions to climate change, how people from all over the world are working toward a more sustainable future. Until then, I'm Caroline, and remember, every choice we make leaves a ripple in the world around us, so don't underestimate the impact you can have. Stay observant, keep asking questions, and I'll see you next time. Hey, hey.